Cement is only to give strength. Correct, no? You are using 43, 53 grade cement. That is there to give strength. But I am using GGBS, which is a byproduct. How it can improve my strength, durability, performance? How it is possible? We can question ourselves, being a civil engineering person. So definitely I am going to explain to you how it is enhancing the performance of the concrete. So when we add water to the OPC, ordinary Portland cement 4353, there are reactions. It's an exothermic reaction. It liberates heat. Okay. So with that, we are going to get the calcium silicate hydrate gel. That is the DNA of the concrete. We see the concrete is set completely. That is called CSH gel because of the binding particle, binding gel. Then one more product, calcium hydroxide, about 25%. We get the whole process, the hydration process, about 60% will be the gel part, 25% will be the calcium hydroxide part, rest is the whites in the concrete, small whites in the concrete, and other products. So when we add GGBS in the concrete, this product, it will react with the calcium hydroxide, which is I can call it as a dangerous element, a cholesterol or a cancer in the concrete body. So that is the calcium hydroxide keep on absorbing moisture, carbon dioxide, keep on absorbing sulfates and chlorides, and it creates dangerous. How we will take care of our body? If you are strong, we can run and do any work. If you are weak, we cannot do anything. So the GGBS convert calcium hydroxide into additional gel, CSH gel formation. So that's how the double reaction will take place. So GGBS is both hydraulic and pozzolanic. Okay. So you take fly ash is only having silica, 55 to 50%. That only 25% is only reactive. I'm going to talk about it in that next slide. Okay. So whereas in GGBS, it is 100% reactive. So these are the diagrams where the hydration of blast furnace slag cement, where you can see the hydration process, where many particles are formed. The interfacial transition zone between the aggregates and the cement bonding, there's a small micro gaps will be there. That's called interfacial transition zone. So that will be reduced drastically because of the hydration more. In the OPC concrete, the gap is always there. So through that water will enter, the chemicals will enter, it will disturb the concrete. Coming to the advantages of GGBS, there are so many advantages of GGBS. It's a green product and eco-friendly product, and it is resistant to sulfates and chloride. The heat of hydration will come down, especially raft foundation when you are making 1 meter, 2 meter, 3 meter raft you are making. So there, rather than the strength of the concrete, the durability is very important. Controlling the temperature of the concrete, because when you make the concrete, the central body will get heated up to 75, 80, 90 degrees centigrade. Because exothermic reaction, it is liberated. It cannot dissipate, no? Because it is confined in the soil. So it will generate a lot of heat. So then the surface will be having, let us say, 35 degrees centigrade. Here, 80 degrees centigrade. The gradient between these two leads to a lot of cracking. To avoid that, we have to use a higher percentage of GGBS, up to 60%, 65%, 70%. The code is permitting up to 70%. We can use so that your heat generation, liberating it, cutting down. Many projects are now adopting the raft rotation, 2 meter, 3 meter, 6 meter up to 60% GGBS there. I'm going to show you the slide also there. So similar way we have made this slag cement also. You can use for the plastering, masonry application. Not only concrete. You can make concrete out of that, but since you are already buying an OPC from so many vendors, so GGBS is there to convert into slag cement. There is nothing but a slag cement only. If you are using 50%, nothing but slag cement only in the making. But you are blending in the silos. You are taking from silo and doing. This is a pre-blended cement, slag cement, which can be used for your all masonry or doing block work. You should use it. All the engineers here, somebody is sending OPC, should give the procurement guide. I will not buy OPC cement from tomorrow. I want only an eco-friendly blended cement. You should talk about that. Similarly, the Advantage of GGBS over fly ash, I've already explained. It's a very good product. It's a manufactured product. It is having higher performance than the fly ash. So here the comparison I was telling, I have shown the oxides, looking at the cement, nothing but clinker, GGBS, fly ash. So you look at calcium oxide, cement is having 62%, GGBS 40% almost. Silica dioxide, cement 22, GGBS 35, it's more than that. Aluminium oxide, cement is having 5%, GGBS 14%. So these ingredients are making the GGBS nothing like cement only. It doesn't have the allyl and belite, CTS and CTS it doesn't have. Okay. So you need certain reaction, a one-day reaction will trigger the GGBS to react. So I told you secondary hydration will start after 10 hours only. So you are not losing. When you look at the fly ash is a pozzolanic activity. The activity will start after 5 to 6 days or 7 days. The cement has to completely hydrate and it has to make it pozzolanic properties to start. Whereas GGBS start reacting after 10 hours only along with the calcium hydroxide. It reacts with the calcium ion. That is the beauty of GGBS compared to fly ash.